Granada, at the forefront of recycling. In 1996, Granada Council set up the first master plan for the treatment of urban waste, which opted for the use of a mechanical biological treatment of the refuse for the entire province. The initial facility fell short in terms of capacity and efficiency to cover the province. However, in 2013, with the start of the Ecocentral Granada plan, the facility was able to provide for the urgent need for waste treatment. This put our province at the head of recycling in Spain, both in terms of processing capacity and recovery of sub-products. The plant has been planned, designed and constructed by the Stadler company, ensuring the plant is equipped with the latest advances in German technology. With over 150 waste treatment plants constructed worldwide, the experience of Stadler is synonymous with knowledge and technical solvency and a guarantee of success for Ecocentral Granada. The project has involved an investment of approximately 20 million euros, financed by European Cohesion Funds, the Andalusia Regional Government and the Granada County Council, which has ensured that Ecocentral Granada has achieved all its objectives to date. These objectives are to increase the recovery of sub-products with the expansion of the capacity and automation of the processing lines, the construction of a new refining plant and another leachate treatment plant, the adaptation of the sub-product storage zone and improvement of the vegetation screens. The Ecocentral Granada plant has a processing capacity of up to 450,000 tonnes of waste per year. This process starts with the reception and weighing of the trucks, which bring the waste from the waste transfer plants distributed throughout the province of Ecocentral Granada. Once the waste is unloaded in the discharge area using a hydraulic grab, the input material is fed into the plant to begin reprocessing. The waste goes through an initial sorting cabin called a pre-sort cabin, where the first sub-product is sorted from the material. This includes glass, ferrous metals, paper and cardboard. And we begin the recycling process. These valuable materials are then deposited in containers for subsequent transport to recycling companies. Any other materials which can obstruct or prevent the recovery process are also removed and transferred to a controlled landfill site. The remaining waste stays on the processing line for sorting. The remaining waste then goes through the first trommel, where the waste is sifted, thus generating two new processing lines. Materials of less than 80 mm, which are primarily organic, and materials larger than 80 mm, which make up the overflow trommel. An electric magnet is used to recover all of the ferrous metals from the organic fractions. This material is then transported to the ferrous press, where it is pressed into bales and sent to recycling companies. Ferrous metals recovered. The remaining organic material is deposited into containers using a pivotal conveyor and is then transported to the composting area of the facility. Through a controlled biological process and with the aid of turning machines, we achieve a stable product which we are able to use as compost, organic material, recovered. In the first trommel, the material was separated into an organic fraction smaller than 80 mm, which left the remaining material larger than 80 mm, also termed the trommel overflow. This flow of waste is still the bulk of the material to be processed. Therefore, it passes through a second trommel, called a package trommel, where the material is classified into the following waste: loose materials ranging from 80 mm to 200 mm, closed bags and packaging material ranging from 200 mm to 350 mm, and the remaining material larger than 350 mm. Using a conveyor belt, the loose material between 80 mm to 200 mm is directly transported to a ballistic separator. The other two material flows separated are transported to a second cabin for the manual separation of paper, cardboard and certain plastic packaging. If the material flow still contains closed bags, the bag opener, which is situated after the second cabin, is designed to remove the material from closed or tied bags. This flow is then fed into the second ballistic separator. The ballistic separators are equipped with rotating and screening paddles. Because of the ballistic movement, we achieve a waste separation consisting of 3 flows. Fine material smaller than 80 mm, which will be incorporated into the organic fraction resulting from the first trommel. The flat material, such as paper and plastic bags, will be sucked up and transported to the second sorting cabin, where a second manual quality control is carried out. And finally, the so-called rolling fraction, which is the richest flow as regards sub-products. From the rolling fraction, we extract aluminium, steel, tetra bricks, and various types of plastic. First, the steel is separated from the other materials by an electromagnet and transported to the ferrous press and then delivered to the recycling companies. Thus, the steel is recovered. The remaining rolling fraction from the ballistic separator now passes through one of the most technical areas of the Ecocentral sorting plant. This material is sorted by optical separation units using infrared rays in order to identify the different types of material. Once the material which we want to separate is identified, the computer sends a signal to send a blast of compressed air, which blows the material into the correct container. To achieve the separation of the different materials, we use 4 cascade optical separators. In the first optical separator, we separate the non-plastic materials from the plastic materials. From here, the non-plastics are classified again by another optical separation unit, which distinguishes the tetra brick from aluminium. At the same time, the plastics from the first sort are also classified by another optical separation unit, which separates the material into PET, the most common material used for plastic bottles, PED, a high-density polyethylene, for example, packaging for cleaning products, and mixed plastics, for example, yogurt pots. Although the efficiency of the optical separation units is close to 90%, all the classified materials are again manually inspected in the quality control cabin to correct any possible mistakes. The flow of waste material ends in the quality cabin, where the different materials will be deposited in bunkers, where they will be stored until they are sent to the baling machines, where the machine compresses the material into bales and labelled, awaiting the collection trucks, which will finally transport the bales to the recycling companies. PET, PED, mixed plastic, tetra bricks and aluminium, all recovered.